Welcome to part 2 of the GIS introduction, Data Formats and Quality. Learning goals for this lecture are the different data types and that you learn how to distinguish between vector and raster data, that you understand topology, and some advice on how to assess data quality. First of all, there are two main types of data in GIS: raster data and vector data. Raster data consists of pixels sorted in a raster, and these are usually images. You could imagine an old TV, and you can see individual points on this TV. So these points are the pixels or the raster cells, and the further you zoom in, the bigger these pixels will get. In contrast, vector data consists of points, lines, and polygons. And you can zoom in as much as you want, but you won't have any of this pixel effect. You can also attach information to the points, lines, and polygons, and then analyze these, calculate a lot of statistics with them, something that's not the same in raster data. With vector data, there is an important concept you need to know: topology. Topology describes the spatial relationships between different vector elements, for example, points, lines, polygons. And these elements or their spatial relationship can be described through proximity, adjacency, that they intersect or overlap, or containment. And in other words, these describe their neighborhood relation. So topology is a formula or a way to describe neighborhood relationships: proximity, adjacency, overlap, or containment. Let's have a look at some examples. So in the top left, you see relationships between different points, and they are in proximity to each other. On the second top image, you see a point in relation to a line, and on the upper line, the point is intersecting with the line. The bottom one, the point is close or near to the line. In the third image, you have a point contained in a polygon or a point adjacent on the boundary of a polygon. And the same for lines and lines in the bottom left, lines and polygons, the mid bottom, or polygons and polygons, the bottom right. At the top, an overlap. In the middle, two polygons, one is contained in the other. And the bottom of the bottom right picture, two polygons sharing one boundary. That means they are adjacent. So topology describes how these elements are located in relation to each other, their neighborhood relation. If there are errors with topology, if you don't map correctly, you can get errors typically like these shown here. These are gaps or little overlap. Often these are little slivers, very small pieces of overlap. And if you imagine or if you think that GIS is used for navigation systems, for example, these small little errors can have a big impact. If there's a gap between two polygons in this case, a navigation system will not be able to guide you from one polygon to the other one. If you have an overlap of the two and then you run statistics, the overlapping area is counted twice and you get a wrong result. And now imagine this is maybe real estate value, and even a few square meter can make many thousands of dollars or euros difference. So you want to avoid such topology errors if possible, and you're using topological editing tools to exactly draw a polygon adjacent to the other polygon without a gap and without any overlap. Other quality measures. First of all, completeness. Ask yourself, is the database overall complete, or are there gaps in our database? Secondly, the precision, for example, the precision of the surveying tool that was used to collect this data. Third, accuracy. How accurate was my measurement? Is the data consistent? And last not least, is it actual? Like, is it up to date? If we have species sightings from 20 years ago, it might still be helpful, but we can't be sure that these species are still around, or maybe their population has changed over the last 20 years. So also ask, how old is this data? A rule of thumb, very common in GIS, garbage in, garbage out. So if your data is not fit for purpose, then your results will not stand up for what you need either. And usually collecting good data quality is the main issue in a project, not the technical analysis. Therefore, some advice on how to improve the data quality. Get a good idea what you and the data users need. Choose only the relevant data. Test the data quality. Is it really coherent? Is it up to date? If possible, use automated tools instead of too much manual editing, because that is usually preventing little mistakes. Check your map and the presentation, and use metadata. Metadata is a description of your data for other data users, like a protocol. Where does it come from? How was it edited? This is all for now about data and data quality. It's a key aspect in geographic information systems.